Hi all, welcome to the online session of Basic Electrical Engineering course and myself Ms. Prathibha PK, Assistant Professor of Department of Electrical, Rajagiri Engineering College. So up to the last class, we were discussing about magnetic circuits. That is, we were dealing with direct current circuit, DC circuits. From today's class onwards, we will be discussing about alternating current fundamentals. That is, alternating current is having both positive and negative. So, we will be dealing with AC circuits from today's class. So, as the fundamentals, we have to start with generation of alternating EMFs. So, for understanding that, before that we have already studied about the Faraday's laws of electromagnetic induction. In that we have mentioned that in the first law it is clearly mentioned that whenever the magnetic flux linked with a coil changes, an EMF is induced in the circuit. So, here we can see how this EMF can be produced. It can be produced in two ways. Either we have to rotate a coil in a magnetic field, or you have to rotate the magnetic field in a stationary coil. These two ways are possible, and in these two ways also the magnitude of the EMF generator will depend upon certain things. First one, it will depend upon the number of turns of your coil, and second one, what is the strength of the magnetic field, and finally at the speed at which the field or the coil rotates. These all are the things on which the magnitude of voltage generated will depend upon. So, you can produce an alternating voltage either by rotating a coil in a stationary magnetic field or by rotating a magnetic field within a stationary coil. So, for understanding this generation, we can refer to this diagram. Here you can see we have a rectangular coil AB which is rotating with a uniform angular velocity of omega radians per second, and the rotation axis is taken as anti-clockwise. Here you can see this is your rectangular coil AB which is rotating with omega radians per second as the angular velocity, and here the axis of rotation is perpendicular to the magnetic lines of force. Axis of rotation is taken as perpendicular to the magnetic lines of force. Here you can see these all are the magnetic lines of force. This is a flux linking is been marked like phi m. So, the axis of rotation is taken perpendicular to the magnetic lines of force. Now, the time is measured like when your coil is in the position XOX dash. This XOX dash is taken as a reference plane. So, when the coil is lying in this position, that is, it is aligned with the XOX dash, that is your reference frame. From that time we are measuring the time. So, time is being measured assuming that when the coil lies in the position of XOX dash, that is a reference frame. So, then it starts rotating in the anti-clockwise direction like this with the angular velocity of omega radians per second. Okay, now the theta is the angle swept by this coil, and theta we can return like theta is equal to omega t. Omega is the angular velocity and t is the time taken which is measured from the reference axis XOX dash. Okay, now we have to write the linear velocity of this coil. So, linear velocity of coil side is equal to, we can represent it as V, which is equal to angular velocity into R, that much meter per second. Linear velocity is equal to angular velocity into R, where R is the radius of the path in meters. So, here R is being marked, from this to this R is being marked, that is the radius of the path in meters. So, you are multiplying the angular velocity with that R will give you what is the linear velocity. Now, we are considering linear velocity right angles to the plane. So, you can write linear velocity right angles to the plane as V is equal to V sin omega t. Now, we can say it as V sin omega t. So, in the next line we can write what is the flux cut per second. So, I am writing flux cut per second is equal to. So, in order to produce an EMF, definitely you have to cut the flux. either by rotating your coil or either by rotating your magnetic field. Here we are rotating the coil with a uniform angular velocity of omega radians per second. Obviously, flux will be getting cutted. So, the flux cut per second, I can write it as B L V sine omega t, where B is the flux density. B is the flux density, unit is Weber per meter square, which already you have studied, or we can write Tesla, and L is length of your coil side. L is length of coil side, that too in meters. Okay, V is flux density, L is length of the coil side, we already mentioned that is linear velocity, and we are considering at right angles to the plane, so sin omega t. So, BLV sin omega t is the flux cut per second. So, what is this flux cut per second? It is nothing but the EMF generated in the coil side. So, in the next line, I am writing it as EMF generated in the coil side, EMF generated in the coil side as BLV sin omega t. So, this is for one side, that is we have considered the radius as r meters, right. So, for this particular side of your coil, you have EMF generated as BLV sin omega t. So, next I have to write what is the total EMF generated for this coil. So, what will be the total EMF generated? This with 2 times, that is you have to consider this portion also, this side also. So, it will be 2 times BLV sin omega t. So, in the next line, I can write EMF generated. So, I am wiping this off. So, EMF generated for the entire coil or for the entire loop as EMF generated for the coil. That the other one was for the coil side, for one particular side. Now we are writing for the entire coil. EMF generated for the coil at any instant t can be written as E is equal to 2 times BLV sin omega t. 2 times BLV sin omega t. And here we can substitute for V. V is nothing but, we already mentioned, that is the linear velocity which is obtained by multiplying angular velocity with radius of the path. So, I can write E as 2 BLV, instead of V I am writing 2 BL omega r sin omega t. So, I obtain an equation like this for the EMF induced for the entire coil. Okay. Next, tell me what is the flux? Flux linking with a coil, or here we can tell maximum flux linking with the coil, maximum flux linking with the coil, phi is equal to, what is the equation for flux phi? It is nothing but it is a product of B and area A, that is flux density into area will give you what is flux. So, B into A, which I can write it as B into, here the flux density already we have mentioned, it is B Weber per meter square, and what about the area of the path? So, here you can see area means we are considered a rectangular coil, isn't it? For rectangular coil, area is nothing but length into breadth. Here length we already written, it is small letter L, and what about the breadth of this entire thing, entire coil? So, up to this is R meters, right? So, the breadth I can take it as R plus R, that is 2R. So, length into breadth. So, I am writing 2LR. Okay, you should not be confused. Area is nothing but length into breadth. Here length L, breadth is nothing but for the entire coil, the breadth can be like R plus R, that is 2R. Substituting that, I got it as 2 times LR. So, this I can substitute here, that is this 2BLR can be substituted by using this phi. So, I can write, therefore, EMF generated at any instant t is equal to phi omega sin omega t. E is equal to phi omega sin omega t. How I got this? Because I have substituted phi as 2 BLR. That is how I obtain E as phi omega sin omega t. Now, next we have to think about at what time you can obtain the maximum EMF. So, here you can see that here we have assumed the coil is rotated at an angle of theta. Theta is nothing but omega t. So, when you think when theta becomes 90 degree, that is when your coil is lying like this, that is in the y dash plane. When the theta value is 90 degree, I can say that sin theta is equal to 1. So, I can get maximum EMF, that is phi omega. So, maximum EMF is generated. Maximum EMF is generated when, at what condition? When your theta is 90 degree, that is when the coil is aligned on y dash plane. So, maximum EMF is generated when theta is equal to 90 degree, that is omega t is equal to 90 degree, because sin 90 will give you what is nothing but 1. So, I can write maximum EMF generated when theta is equal to 90 degree, which I can write it as EM is equal to, I can, this will become 1 at that time. So, EM is equal to phi omega. This is the maximum value of EMF generated, is nothing but phi omega, because sin omega t became 1. Okay. Or here I can specifically write not theta, I can substitute it as omega t is equal to 90 degree, because we have written like sin omega t. So, EM is equal to phi omega. So, if I am putting this as equation 1, I can substitute this in equation 1. What I can obtain? Substituting phi omega as EM in equation 1, we can get E is equal to, that is EMF generated at any instant small e is equal to EM sin omega t. We can put this as equation number 2. Okay, this is the equation for maximum EMF generated EM sin omega t. Similarly, we can write the equation for instantaneous value of current also, which is represented by small letter I. Always care about that, take care about that. Instantaneous values are given in small letters. Okay, I is equal to, similarly I can write Im sin omega t, putting it as equation number 3, where Im will be the maximum value of alternating current generated. EM we already mentioned, maximum value of alternating EMF generated. So, I is equal to Im sin omega t. And now, we are assuming that the frequency is F. F frequency means number of cycles per second. If we are assuming F as the frequency here, then I can substitute omega as 2 pi f. Okay. Angular velocity omega is nothing but 2 pi into f if f is the frequency. Frequency is nothing but number of cycles per second. So, I have to substitute this 2 pi f in this equation 2 and 3. Then I can rewritten as, then instantaneous alternating EMF E is equal to EM sin 2 pi f into t, and instantaneous current I is equal to Im sin 2 pi f into t. So, this is an important relation which you should remember, because we will be doing problems with all these equations. So, how to find out the instantaneous value of EMF and how to find the instantaneous value of current. Okay, for that you need to understand these two equations, you need to remember these two equations, E equal to Em sin 2 pi f into t and I is equal to Im sin 2 pi f into t. Now, these values when you are going to plot as a waveform, how it will be? We can draw that. that is you are taking EMF value on the y-axis and your theta or omega t on your x-axis. You can plot the waveform as like this. This will be your waveform. Here on the y-axis you are marking EMFs and here you have theta which is equal to omega t. So, this is your maximum value, that is nothing but EM. This EM is here. At this point of time you are having maximum EMF and this we can specifically write as plus EM. Similarly, you have in the negative direction also, so this will be minus EM, maximum value. And the cycles we can mark 0 to pi, so this will be pi by 2, 3 pi by 2 and this is 2 pi. So, this is the waveform of an alternating EMF. So, this diagram shows the waveform of an alternating voltage and here I can mark one cycle as this much duration. This is known as one cycle. Okay, here in one cycle you can see that there is two alternatives, one positive and one negative, that is alternating EMFs. For in one cycle you have two alterations, positive and negative. Now, here if I am marking the outline as A, B, C, D, E, I am marking the envelope as A, B, C, D, E, then this forms the waveform of alternating EMF. Okay, A, B, C, D, the envelope A, B, C, D shows the waveform of an alternating EMF. Now, we have to study different terms of an alternating quantity. It is very, very important terms. You have to study the definitions also. So, first you can give the title as important terms. What are the important terms of an alternating quantity? So, first we have to discuss about what do you mean by a cycle. First term, let it be cycle. How can you define a cycle? Here we have marked this is one cycle. So, how can I define this one cycle? One cycle is nothing but a complete set of positive and negative values. Complete set of positive and negative values will constitute one cycle. So, cycle you can define as the complete set of positive and negative values of an alternating quantity is known as a cycle. That is being marked here, complete set of positive and negative cycles. Okay. The next term which you have to study is, what do you mean by time period? What is time period, or it is represented by capital T. So, what is time period of an alternating quantity? So, from here you can see that time period is nothing but the time taken for one cycle is called time period. Cycle is nothing but complete set of positive and negative values of an alternating quantity, and the time taken for one complete cycle is called time period T. And the relation between time period and frequency is mentioned as T is equal to 1 by F, where F is the frequency. So, the next thing what we have to define is nothing but what do you mean by frequency? Frequency, already we have mentioned in that equation, we are assumed F as a frequency. So, frequency is nothing but the number of cycles per second is called a frequency. So, in our country, in India, the frequency of alternating current is assumed to be as 50 hertz. That means, in one cycle or in per 1 second, you will be having 50 cycles. This is one cycle. So, 50 cycles will be there in 1 second. So, frequency is nothing but number of cycles per second. And what is the unit of this frequency? It is hertz, or it is written like cycles per second. Hertz or cycles per second, and in India we are adopting 50 hertz as the frequency of alternating current. And in abroad in US and Canada, they are adopting 60 hertz, and in Japan, I think both 50 and 60 hertz they are using. Okay. And next thing what you want to study is, what do you mean by amplitude of an alternating quantity? What do you mean by amplitude? The maximum value of positive and negative values of an alternating quantity is called amplitude, or it is simply referred to as peak value. Peak value. Amplitude is nothing but simply we can tell it is a peak value, that is the maximum positive and negative values of alternating quantity. In the figure we can see EM, it is there in positive direction, and minus EM in the negative direction. So this is known as amplitude of an alternating quantity. So we have discussed what you mean by cycle, what is time period, what is frequency, and what do you mean by amplitude. Now the next one is, what is average value? Average value of an alternating quantity is nothing but we are taking the arithmetic mean of quantities. Arithmetic mean, but it should be taken like arithmetic mean of ordinates over a half cycle of the waveform. Why we are taking half cycle? Because if you are considering for the entire full cycle, we can see that for the entire cycle the average value will become 0, obviously, because one is in the positive direction, other one is the negative direction. So we have to consider only the half cycle. So average value is defined as the arithmetic mean of the ordinates over a half cycle of the waveform. And in the later classes, we will be discussing about the methods to find out the average value of alternating quantity. And another one is, the last term which you have to learn is, what do you mean by instantaneous value? What is instantaneous value? The value of an alternating quantity at any instant is known as instantaneous value. Instantaneous value is always denoted in small letters. That is why we have written small e as Em sin omega t and small I as the instantaneous value of current, that is Im sin omega t. So instantaneous value of an alternating quantity is nothing but the value of the quantity at any instant. So these terms you should remember, and there is one more term, that is RMS value of an alternating quantity, which we will be discussing in the next session. RMS value and how to find out the RMS value and average value of a sinusoidal waveform, that we will be discussing in the next session. Thank you.